Greetings of the day, wherever you're dialing from. Welcome to the September lecture, but one with a difference. Today, we are collaborating with CBTYM, and we will be talking about some fantastic work they're doing, young members are doing down in Brazil. This happens to be our third joint lecture with an organization from outside UK. Throughout the lockdown, we have tried to bring more international content to our members here in UK, but also we've tried to support other young member nations globally. So once again, thanks for your patience with our lectures over the lockdown, but more so, thanks a lot to CBTYM for agreeing to do a collaborative lecture. So on that note, I'll transfer over to Tiago, who is representing CBTYM today, to introduce our speaker for the day. Tiago, over to you.
Hello everyone, good afternoon. So in our lecture today, Pedro Paulo Anjos is going to present a lecture about this implementation of Tamoios road project. So Pedro is 29 years old. He has an exchange in England back in 2012-2013 to learn English. So he's a civil engineer, graduated in 2013 at the Federal University of Campina Grande. In 2014, he joined Queiroz Galvão, which is a Tier 1 contractor in Brazil for major infrastructure works. And in 2016, he completed a MBA in project management by the FGV. So, Pedro, can you start, please?
Okay. First, good afternoon for everybody. I thank Divik and Tiago and everyone present on this online for this webinar. First of all, I'd like to say I'm thankful for CBT and BTS for the opportunity to be here today representing Brazil and sharing some of our innovations and technologies that we are applying in this important work here in Brazil. I'm appreciated the invitation, and I hope that who is watching now, students, engineers, and other professionals, enjoy what are you doing in this amazing work. Okay, so I'm the design coordinator in this work. I'm the responsible for the designers, their interface between designers. I'm responsible for the topography team and the geologists and instrumentation team. Okay, with me today there is another engineer, Gustavo, to help to talk about some topics and response any questions or doubts. Please, Gustavo, introduce yourself.
Hi, good afternoon. Hi, Devek. Hi, Tiago. Hi, Pedro. I'm Gustavo Santos. I'm 28 years old. Like Pedro, I'm a civil engineer as well. I worked in a building construction company and then an inspection building company. But now it's my first project here in Tamoios with tunnels and viaducts. My first huge project. Let's start, Pedro.
So let's start the presentation. So here we have a short presentation plan with some topics that we are going to talk about in the sequence. So we're going to say quickly about the company, the project background and the overview, applied methods and technologies, accessibility and emergency and tunnel equipment, the reduction of environmental impacts, and the good practice of this contract. So we have here a resume of the group Queiroz Galvão with more than 67 years of history The company operates in national and international markets and has experience executing work with innovative engineered solutions in several sectors, such as infrastructure, such as highways, airports, bridges, pipelines, buildings, railways, subways, power tunnels, power generation, and the underground works. And in this segment, we have more than 300 kilometers executed. So, as we're talking about tunnels works, I'm gonna show quickly another important projects of the company. This work in Brazil, it was the Metro 4, is in the northeast of Brazil, as you can see in the map. It was a work with the method, with the cut and cover with diaphragm wall. Here we have the line 5, the metro of São Paulo. We have here the method was the NATM and the TBM. In this case, the NATM was to did the shafts and the TBM for the tunnels. Here we have the line 4, the line yellow, São Paulo, the metro São Paulo. The method used was the NATM and TBM. In this case, we have 4.6 kilometers of NATM tunnels and 6.3 kilometers of TBMs. Now here we have the line 4, but in this case in Rio de Janeiro, okay?
And this tunnel here, we used both NATM and TBM as well, with over the section over 100 square meters.
We have here the road tunnels. This one it was made for create a connection between the countryside of Minas Gerais, I stated here, a rich region in iron ore, to a region in the state of Rio de Janeiro, a steel industry region, and the Queiroz Galvão construction was hired to build a lot with almost 28 kilometers. In the total station of this project, it was 350 for 100 kilometers and almost 100 tunnels in the total. The biggest one with 8.6 kilometers. Some hydraulic tunnels. Here we have a work in Chile. It was a power station in Ligueira, in the city of Ligueira. In the total, we have 19 kilometers of NATM tunnels. Another one power station, Queimados, now in Brazil, but in the southeast of Brazil. We had a total extension of 4.6 kilometers, and the method used was an ATM. Here we have the highway tunnels, important highway here in Brazil, the BR 101. It was in the south region, as you can see in the map. We used the NATM, soil and rock, and the section was 125 meters. The total extension was 3.7 kilometers. We have here the Rodonel Lot 5. It was a ring road around São Paulo. The total extension was 3.4 kilometers. The method used NATM to the rock excavation, 630,000 cubic meters of material. Here we have another work in progress. This one in Salvador, Bahia, a state of Northeast region. It is a connection between the littoral, the Atlantic coast, to the center of the capital of Salvador, the capital. This work have 3 tunnels and almost 12 kilometers with 3 lines each direction. Here we have to create a connection with the Tamoios and the port. I will explain better later, but this project in specific is going to connect the Tamoios Highway when in operation, as illustrated in the next slides I will show. This work that we finished recently, I had the privilege to participate from the beginning. It was more than 12 kilometers of tunnels with a section of 105 square meters, and we used it to the NATM method. Okay, it was a double tunnel with a section around 105 square meters. So now we've got to the point. Let's discuss about the Tamoios Highway. Okay, here's some key information for the project. This work is located in the north coast of São Paulo. The city it is Caraguatatuba. We have almost 13 kilometers of tunnels and 10 viaducts or 10 bridges. The method chosen was the NATM 2. And so let's start. The Tamoios Highway, it is a crossing the Serra do Mar State Park. The duplication of Tamoios Highway will provide more safety for the users with smoother ramps, less sinuous roads, and more open curves. In addition, it will improve the flow capacity of products to the port of São Sebastião, moving the economy. Due to the differentiated technology solution to reduce impact on the Atlantic rainforest, the project received in 2017 the Eco Sustainability Award from the American Chamber of Commerce, okay, an international entity. Here we have some technical information. So we have almost 22 kilometers of long main track. We have 6.1 of earthwork, 12.8 of road tunnels, including the biggest one in Brazil with 5.5 kilometers. And we have 2.5 kilometers of bridges. It's important to say that almost 85% of this work is inside this park, the Park Serra do Mar. Is located in an environmental protected area and with several species of animals and plants. So more than 80% of these works is inside a protected area. So here we have a layout of the project. As you can see here, we will have the Tamoios Highway, the new one in the green line, as you can see here, is the what are we doing now? And this route will be the uphill way with 2 lanes and a shoulder, and they would be the old one. This yellow line will be the downhill way with 2 lanes too and a shoulder. From a technical point of view, the relief of the mountain make it difficult to build tunnels in this area, as we have a region with many valleys and hills associated with heterogeneous geological conditions. The weather conditions are another important factor, since we are talking about a tropical forest. Okay, as you can see in this picture here, we have the plateaus, the top of the mountain here, and we have the plains in the level of the sea, and we have a height difference in almost 650 meters. And with this, we can see the difficulty of the topography, the climatic conditions, and another aspects.
Yes, those were the big challenges here, to bring the highway from the top of the mountain to the sea level, and also to build the viaducts and tunnels inside a protected area. So I think if we summarize, those are the challenges.
So here we have the layout of the project, the total project. As you can see, we will have the Tamoios Highway, the connection with these roads, the contour works. So we have the yellow line is the duplication, the uphill way, and we have the red one and the blue one. It is the contornos works. Okay, the contorno works connect with the Tamoios, and with this leads to the port of São Sebastião, an important logistic center in this region. This port, in special, has a better conditions of operation than the port of Santos, one of the main Brazilian ports. Okay, it's a secondary port for the state. With this, we have an important project for the economy of the state and the economy of this country. Okay, so we have here the layout of the work, the Tamoios duplication. Here we have the actual road, to access the north littoral, and we have here the old one, as we name here. This project includes the construction of 10 viaducts, as you can see here in yellow, and 4 tunnels. In the total, we have a stretch of 21 kilometers of extension. We have 4 tunnels, the tunnel 1 with 2.9 kilometers, the tunnel 2 with less than 1 kilometer, the tunnel 3, 4, 5.5, the big one, and the tunnel 5 with 3.7 kilometers of extension. So we have here the viaduct 6 with almost 1 kilometer of extension. Okay. So we have here a board with contractual data. The client, it is the concessionaire Tamoios, the source of resource, the state. We have the investment close to 600 million pounds. So for here, it is a biggest work. It's a big work. The service award was April 2015, and the deadline for March 2022. Today we have a physical advance in around 78%. The object of this contract is the implementation of the Nova Tamoios Highway and the duplication between the kilometers 60 and 82. So we have here this board. This table presents the main quantities of this project. So we have here a resume, 4 tunnels, 10 bridges, earthworks bridge, the largest bridge with 948 meters in the total station of this project. The main quantities of the service, we have the excavation more than almost 2 million cubic meters of excavated material, concrete paving and asphalt paving, almost 50,000 cubic meters, shotcrete and structural concrete around in 260,000 of concrete cubic meters. So we have here a sum up. We summarize some topics, and we are going to talk about the sequence. We have the utilization of TCADE, the software TCADE, the section scan, the cable crane assembly, the tunnel 2 breakthrough, and the viaduct 1A. So we have here the applied methods and the technologies of this giant work. So you have here, just to explain, the NATM is a commonly used excavation method using the drill and blast technique, consisting of rock drilling and detonation of explosives in the tunneling fronts in rock masses. So we have some stages of the cycle, and Gustavo, if you want, you can put some.
Sure. It's a pretty common method. First, we have the geological mapping with the topography team, then the front drilling with the boomer. After this, we have the explosive loading, then the detonation, and after that, we have the ventilation system for the gas removal. Then we have both mechanical and manual scaling, and finally, the shotcrete, our sprayed concrete here. And the cycle repeats over and over until the tunnel is done.
We have here the emergency tunnels. For reasons of regulation of the fire department, tunnels over 3 kilometers must to have a pedestrian crossings every 250 meters for better evacuation in case of fires or accidents. For this case, along the 3 tunnels, Tunnel 5, Tunnel 3-4, and Tunnel 1, there is a parallel service tunnel. Only Tunnel 2 doesn't have an emergency tunnel because it's less than 1 kilometer long. All the passages will be fire protected. So we can see, so let's return here. The main section, we have a cross section here of the double tunnel. We have the main section with 120 square meters. We have the cross passing. The distance between them was around 16 meters. And we have here the service tunnel with 33 square meters of section. So, as we said before, every 250 meters we have to have a connection tunnel. But in this case of the tunnel 3-4, as we are talking about a tunnel with 5.5 kilometers, the fire department regulation demands a massive extraction or a ventilation tunnel. Okay, this ventilation tunnel will be equipped with 6 fan jacks with 150 horsepower each one, which will be activated in special cases such as fire or high gas concentrations. So we have here the service tunnel and the main tunnel, and between them there is a chamber with the power plant, and we can see here the six fan jets for the massive extraction. Okay, so we have here a plant view, and we can see in this region we have many types of excavation section in the same region. The main section, the service section, the connection, and the shaft section. We can see here through the chamber with the operation, a controller room, and a power plant of this tunnel when in operation. Okay. So Here we will say about the boomer system. It's not innovation, but as we're talking about work with 80% of tunnels, it turns a crucial tool to perform the tunnel cycle and the excavation control. We bought in the beginning of this work 6 equipment like this. This model in specific has 3 booms and the TCAD system. We have some here examples of the reports. We can export some information like drilling speed, the water pressure, hose depth, and another important data for the operator at real time. So we have a significant improvement in the drilling accuracy, decreasing the amount of under and over break, reducing with this, of course, the waste of material involved in drilling. And this is a partnership with Sandvik, a Finnish company, and all the operators was training and the maintenance equipment to control and to optimize the entire cycle of activities related to the jumbo. Okay, so we have here the topographic equipment. We have here a total station. It is a robotized station, and this equipment is responsible for the geopositioning of the jumbo, and it's located the drilling holes and maps the excavation section. With the aid of the systems, an autonomous system, we are able to collect information and compare section in real time. Okay, so this technology guarantees the treatment and under break points and drilling adjustment for the next blasts, minimizing rework and loss from over excavation. Okay. These slides represent the important stage is the stage which the topography team is responsible. It is one of the most important team in underground works. Here are all the service the topography team executed in a tunnel excavation. As you can note, they participated in all stages of the excavation cycle. So we can control the quality of lining. We can have the real-time profile. We can back up and set up the section and another service that we can control in real time. Okay, in the shotcrete time, all the treatment, all this, the excavation and others. So here we have. It's important to mention this work in Brazil today is the first one to
use only polypropylene fibers to resist fires and structural loads.
And this can be achieved applying in the shotcrete mix an addition of micro and macro fibers. Okay, it's important to mention again. We are doing some pioneer thing here in Brazil because we are doing the tunnel lining with 100% of synthetic fibers, and this solution improves for the shotcrete and for the cycle of excavation other advantages. Another interesting point is that with these results obtained in this work, we are preparing together with other technical institutes the Brazilian standard for the concrete reinforcement with polymeric fibers. Okay, for this it is an innovation of this work.
changing the steel mesh for these fibers, we are achieving greater work without a more safer way, a quicker and cheaper way is the result of this change.
So this is a not innovation system, but we choose this solution because any factors of this work, and there are some points that we can talk here. The system allows the adherence between the first shotcrete line and the second one, preserving the friction between both layers, allowing a significant reduction on its final thickness, providing with this, of course, a financial and a time economy in the cycle of excavation too. It has a lot of advances over the waterproof membrane system, a usual system. It is a not systematic treatment, therefore not only cheaper but also easier to apply. Dealing with infiltrations with high flow rates, as commonly find in tropical regions and rainforests, reduce groundwater pressure over the lining, avoiding overload due to extreme climatic events. And when necessary, we can combine this system with short rams, as you can see here in the image, and a polymeric mortar in order to maximize its efficiency. So nowadays, the environment is a central subject in discussions about the society in the last decades. When we are studying the project, our prime goal was to attend the environmental and the contractual regulations and the good practice of engineering. So let's talk about the most important and the innovation of this work, the cable crane. So from the beginning of this project, the company looked for different solutions around the world to avoid the execution of this service way, as you can see here in this orange line. Okay, that would suppress more than 400,000 square meters of rainforest, a big impact in the Atlantic forest. Because our short deadline, we had to start the viaduct tree and the tunnel tree at the same time. That's why we had to employ this pioneer technology in Brazil. So it's the first cable crane assembly here in Brazil. So it was a hard mission to do this for the first time. Okay. As you can see here in this overview, we designed the position of the track rope, the red one line here, aligned with the main supports of this bridge to aim the execution of foundations, columns, and other structures of this viaduct here.
Yes, the track hope is right here. It's placed here because of the viaduct here, the main supports, and also to help in transporting the rocks from the tunnels to its final destination.
So let's talk about the cable crane mounting details. In the case of Tower 2, we could assemble with crane, regular crane, because we had enough space to do the operation. As you can see here, we have all this space and we can do a regular or standard operation. However, for the Tower 1, that was not possible. This region here was unreachable. As you can see, the helicopter and all this earthwork here. That's why we decided to install each piece using a helicopter. As you can see in the video, this is the tower one. This is in remote region inside the park. Okay, so it was so hard to have this liberation of the park to do this operation, but we can prove that that wasn't impact with this operation. So we have a partnership with the Omni. They're responsible for the helicopter, and another partnership was the LCS, the cable crane construction. But all the project was made together with LCS, the Omni, and the Queiroz Galvão. Okay, so all this operation was made together. We have here some technical informations about the cable crane. The distance between towers, the tower 1 and tower 2, it is 394 meters. The track rope, the diameter is 65 millimeters. The load capacity, about 20 tons. The travel speed, 4 meters per second. And the turret height, tower 1 with 42 meters and tower 2 with 35 meters. As you can see in the videos, we can carry any types of equipment.
Yes, I was in charge of the night production shift here in Tamoios, and the cable crane was essential. Every steel bar, every concrete, every framework, every equipment in general was transported by the cable crane, so it helped and was essential.
So we have here some operational data. The period of operation was since March of 2019 until August 20. We worked 7,1,200 hours. The soil rocks transportation more than 220,000 tons. The concrete volume more than 10,000 cubic meters, and the mechanical availability approximately the 90% of utilization of this equipment. So it was very efficient for this work and very important to us for the conclusion of this bridge. And we can anticipate the deadline of this bridge in almost 2 months, and we can anticipate the tunnel close to 5 months. So we have here another solution, the pedestrian walkways for optimize the path along the viaduct tree and to access the main supports. With this, we can reduce the dislocation time of the workers, and we can avoid unnecessary suppression below the bridge. Okay, we can see here the tower, the height of the tower, almost 30 meters of height, and we can assemble this tower with the aid of the cable crane too. Okay, so for this, the cable crane supports all the operation in this assembly. So in the basic project, we expect to have an impact over over 700,000 square meters. However, with the all engineering solutions, we had a positive impact, reducing close to 40,000 square meters of suppression at the Atlantic forest, the equivalent to 6 football fields like the Wembley Station. So we can see the reduction was very important for the this work, and we can finish this bridge and the cable crane supports for this goal. Now let's talk about the water treatment stations. Just for just to we have an idea, during the drilling process of the tunnel, the boomer consumes about 40 cubic meters of water per cycle of excavation. So a work like this, with this proportion, we can consume close to 400 cubic meters per day. So this system was developed in closed circuit. All the captured tunnel effluents, the infiltration water or post-drilling water, passes through the treatment station. Therefore, there is no risk of dirty water disposal, providing protection for the environment and reducing the operational costs. So we have here each tunnel have a water treatment station to treat all the effluents. We can see in this graph here the total volume in 2019 in cubic meters. We treated more than almost 300,000 cubic meters. The reused water was 120,000 of cubic meters, and discarded water and concrete plant water volume, that is another volumes of water, all them treated. You use more volume of treated water than our well. So with this we can avoid the unnecessary natural water consumption. Our primary reused water destination is the tunnel drilling to attend to the demand of the jumbo, the equipment washing, the crushing plants, and the access routes for route ratting. So for just for we have
An idea of how much
we treat in 1920, we treat the equivalent to 115 Olympic swimming pools. So we can see other images and the quality of this water. We control all the parameters like pH, like another sulfates and another parameters of control of this water. And this water is portable. So we have here the crushing plants. This is a substantial project, and the total volume of the earth moved, include rock generated by the tunnel excavation, will reach 2 million cubic meters. Much of this excavated material will be used in concrete, in the asphalt plants, and the soil plants. The volume necessary to all civil works will demand more than 300,000 cubic meters of concrete.
Yeah, basically we take the rocks from the tunnels, we drill, and then we have the crushing process, getting the gravel and the rock filler, and we use them in the shotcrete, in our sprayed concrete, in our concrete, and in our paving, reducing natural waste. and costs.
So another solution we have here is a situation of the tunnel 2 breakthrough. So that we didn't have access to, as the case of the viaduct 3 and the tunnel 3, to assess the other side of the tunnel excavation. But in this case of tunnel 2, due to environmental limitation, we had to dig from just one side. With that, we had to break through the tunnel from the inside out, okay? To save the time in the execution of the viaduct, we thought in a solution to assemble the viaduct inside the tunnel and then push it with hydraulic jacks over the supports. So with this, we can save time and we can deliver for the client this bridge in the deadline as the demand. So that's for the good practice of this contract. So we have here some items that we summarize the another points or the some points. Principal and service tunnels approximation. We adjust we reduce the interconnection tunnel length, decreasing the total area of treatment and the suppression even. The shotcrete technology control, the use of 100 filler and the PP fiber, the polypropylene fiber in the shotcrete mix design. And with this, we did not use a natural sand in the mix, improving with this efficiency in the results and the quality parameters and reducing the need for material deposits. The cable crane assembly, a solution for reducing the environmental impact and making the executive schedule viable. In the first time in Brazil, a pioneer. And the tunnel 2 breakthrough in viaduct 1A. It was a differentiated solution, saving time and protecting the environment. So with this, I think we finished the presentation, and we have here some contacts. We have here my email for any questions. We have the construction site and another social medias. Okay, I think is this for today.
Thank you, David.
I have to thank and appreciate it again the opportunity of the BTS and the CBT. I thank to Gustavo to be here with me today. And what do you want to complete?
And a special thanks to of the people who worked here with us, more than 1,000 people that made this dream come true.
Thanks.
So after the Q&A, just a note to those dialing in. If you want to ask a question, please type your question in English or Portuguese within the comment section of YouTube. And I think I've got a quick question for you, Pedro. So you briefly touched on the contract. Now, I'm not quite aware of what conditions of contract you use in Brazil, but was it a cost plus contract, or do you have a similar system to what you've got on major infrastructure projects in UK, where you've got a pain and gain share mechanism? That is, if you exceed the budget, then the client and the contractor shares a bit of that additional amount, or if you come under what was the initial amount, then you basically share the profit as well?
No, our initial amounts, we are using it, and we are on track of what we expected.
And that's quite good. I think that's a success in itself, isn't it?
Yeah, we are successful. And type of the contract.
Yes, it was a turnkey lump sum, the type of the contract.
Ah, okay.
So we have this condition, and we have the price of the contract is locked, something like this.
Okay, yeah, it's a turnkey lump sum, so makes sense. Fantastic. Thanks for the answer to that. We've got questions started coming on YouTube. So Tony asks, the cable crane approach was the highlight for him. This was amazing. So that's just a compliment to you. Then we've got a question: do you only use shotcrete to support, or there was any type of anchoring?
We have boats, but are provisory boats. It's not a definitive boats, but it is associated with the shotcrete, reinforced with micro and macro fiber. But the boats are just for the initial loads, but they are provisory boats. Okay.
So, thanks for that. On the topic of the fibers themselves, so did you say you used polypropylene macro as well as micro?
Yes.
Was there a reason why you didn't go for steel fiber?
A reason why we use both lengths, both diameters.
No, but you use both polypropylene.
Yeah, they both are polypropylene.
Yes, because we have two layers of concrete here in the tunnels. The secondary layer is the fire resistant layer. So the microfibers are for that.
Yeah.
But the first layer is a structural layer, and we are using the big one.
Yeah, the macro.
Sorry, guys, what is the thickness of the tunnels, of the lining?
Between around, it's ranging, huh? Range between 15 and 40 centimeters.
Depends on the geological condition.
Yes.
So are you using RMR or Q of Barton to classify the rock mass based
Barton.
on the advances? Barton?
Barton.
All right.
So just one to the attendees, if you got any questions, please do ask them now. Oh, we've got one from Mehdi. So Mehdi asks, what type of environmental study was carried out prior to the start of the project? What were the major risks? And what was the performance compared to the study?
Well, the major risk was the impact in the park. Is a park with primitive conditions, so it is a virgin forest, and the major risk it was the contamination or pollution of the some river or a suppression. So we control every month with reports. We send reports for the client, and we are
We are doing great. We are doing great.
Yeah, we are doing great from the beginning. So we can control the risk when we have a good monitored team and a client is very tough in these subjects. So we can have to be more aware with this.
Let's see a Brazilian question. Let's see if we have a Brazilian question here.
Fair enough. So, just on just touching on environmental impact itself, how dry is your tunnel? Do you get substantial water ingress? And if you do, how does it replicate into changing the water levels in the adjacent areas?
Sorry, Devik.
Do you get substantial water ingress in your tunnel? How dry is the ground? And
Okay.
So first we in the excavation cycle we have to map if we have some flow, some high flow rates of water, and with this we identify the localizations for do some treatment, some punctual treatment. So we can do some short drains, some polymeric mortar to complement, to combine with the system, the drain pack system. Okay, so we have to map and to treat each region of the tunnel. Some regions are more dry and some regions are more wet. Depends of the relief and depends of the type of rock, depends of the any factors of the front of excavation and another points like this.
Sorry, but did you start tunneling without knowing if there was any water present or not? About water levels or flow?
Oh no. We have studied this issue, and we have all the instrumentation before they start.
Yeah,
Fair enough.
we have some profiles along the tunnel, but this level of water have some variability along the relief and the topography and the cover of the tunnel too.
have you seen any impact on the local groundwater levels, or has the impact just been negligible?
No, no impact.
Reassuring to know.
Didn't have impact
in the groundwater.
Oh, that's good. Tiago, I think we've got a question in Portuguese. Do you want to pick that one up?
Let me see if I can read this very small screen, but okay, I can see. So, in parts of the project with low quality or medium quality, the geomechanics of the excavation on both tunnels, the treatment was very restricted based on different tunnel lining thickness. Okay, so
that depends.
oh no, the question is about what was the difference between the thickness based on the geomechanical assessment of the rock mass.
Yes,
how the rock mass impacted on your lining thickness.
Yeah, the worst rock quality we applied something like 40 centimeters of shotcrete, and the better one with a high quality of the rock. We just apply something like 13 centimeters of shotcrete. So we have this difference.
Yeah, it depends. We have a scale from 1 to 5, the rock's quality, and depends on it.
We can classify.
They classify.
Depends of the classification of the rock, and this thickness is around 13 for 40 centimeters.
I have a question. Have you crossed any rock faults between during the alignment of the tunnel? And if yes, which treatment have you used to cross the fault?
No.
We didn't cross, but we have here the rock busts. We had in some situation, sometimes when we have covered more than 300 kilometers of cover, we had some rock bursts. But with the instrumentation, we just pay attention more the instrumentation, and in sometimes we did reinforced. We put some a mesh of steel. We have to do the NATM. We can gain some treatments. Depends of the rock and the instrumentation reports. We can adjust this treatment. Is the NATM is because one of the reasons that we choose and the NATM is because this situation here too.
Okay.
Explain it.
Good to know.
Oh, yes, sorry. Yes, thank you very much.
We're being mindful of the time, so just one for the audience. If you've got any further questions, do ask them now. We'll probably take another couple and then bring it to a wrap. Is that another one in Portuguese we've got, Tiago?
Yes, we have another question by Ana Paula Ruiz. What was the length of the advances according to the quality of the rock mass?
Yeah, the biggest one, it is 5 meters per day in a good quality of rock, and the worst quality, almost soil, we have advance around in 1 meter or less, 50 centimeters, something like this, but depends.
So, on the note of, I think we were discussing about rock burst, but did you get any substantial convergence as well in areas with high overburden?
Sorry, David.
Did at any point did you get substantial convergence in the tunnel, or was the observed convergence always within your tolerance?
The tolerance line, it is this, or the convergence? You are saying you are talking about the convergence spines. It is this, the instrumentation.
Yeah.
Is this? So we have here the instrumentation team is my responsible here for, and we have equip a team of designers here to reports and to follow to analyze these reports every day. For in few situations we have some different situation in this work. So the convergence and the divergence of these tunnels is normal. It's not
It's in the tolerance.
Is in the tolerance, nothing strange.
Okay, thanks for answering that. We've got another question regarding the shotcrete lining. Regarding the shotcrete lining, the first layer was part of the permanent tunnel support. Do you have a measure of economy led by the solution or reduction of the total lining thickness? So do you have a comparison between what the thickness and the cost would have been if you didn't use the
Steel
well,
mesh.
yeah, if you've used the steel mesh.
Department, tunnel support, do you have a mission? Yeah, we have uh, a large economy. Um if you compare the steel mesh with the synthetic mesh, the synthetic fiber, you reduce the cycle of excavation. You reduce the equipment necessary to put the steel mesh, and we have a lot of economy points and a lot of advantages when we use the fiber. But in value, I don't have the value now to say how much or how we save in this contract, because this difference, this concept of the steel mesh and the fiber. But you can you can do this discount if you want. But depends of the work, depends of the section, depends of the project, depends of many factors, and you have to put this in a sheet. It's not so too easy to do this. Okay.
Fair enough. Thanks for replying to it. I think being mindful of the time, I think it's we better bring the Q&A section to a close. So once again, thanks a lot, Pedro and Gustavo, for your great presentation. I think it's quite evident from comment section how much people enjoyed it, and very rightly, it appears to be a very challenging project, to which you've found a really good engineering solution where you're delivering what's required within budget, but also reducing your impact on the local ecology. So, congratulations to you and your organizations for achieving this. Before we wrap up, I've got a few announcements to make. So, the next BTS lecture is on the 17th of September. The lecture is titled Hydrophobic and Pore Blocking Ingredients for Use in Tunnel Construction. The timing for the lecture is 6 p.m. UK time. But if you subscribe to our YouTube channel or follow us on social media, you can see our social media handles on your screen right now. You would be able to get a notification of when the lecture is. Later in the month, we have another BTSYM lecture in conjunction with the Institution of Civil Engineers London Graduate and Students Committee, but also TAC-YM, so the Tunneling Association of Canada Young Members. And the presentation will be about lessons learned as a trenchless litigation expert and designer, and that will be presented by Dr. Mark Knight. And the final note from my side is, if you're dialing in from UK and you're a young member, the applications to our committee will be opening soon. Once again, if you are interested in joining the committee, do follow our social media and you will be able to spot the link when we share it, which should hopefully be sometime next week. So on that note, I will hand over to Tiago to do the closing note on behalf of CBTYM. Over to you, Tiago.
All right. First, I would like to thank you, Pedro and Queiroz Galvão, for the presentation. It was really good indeed. And also, I would like to thank the BTS young members as well for the opportunity for the Brazilian Tunneling Committee for presenting and sharing some knowledge. And also, I'd like to thank the CBT as well for all the support and all the webinars. If you want to watch the previous webinars and also this one, you can follow the channel on YouTube. And yeah, I think that's it from me.
I think, Tiago, thanks are in order to yourself as well for getting us in touch with Alex, but also Alex himself for taking the idea overboard and, you know, contacting Pedro. And without
Oh, yes,
yourself
yes,
and Alex, we
sure.
wouldn't be having this presentation today. So thanks to both of you.
Thank you.